Hello, everyone. My name is Michael Kleiber, and I'm the AI runtime lead at Encharge AI. It's my pleasure to speak here today at TVMCon23 and introduce UMA, the Universal Modular Accelerator Interface, to you. As you can see from the number of contributors here on the first title slide, UMA is a community project from Encharge AI, University of Tübingen, University of Munich, and Bosch Research, and is also maintained as part of the community. The initial steps towards UMA started a little bit more than a year ago, have made it into main in August, and it's even now part of TVM release 0.11. Why did we build UMA? The main motivation was that we, a group of people that can now be considered the UMA community, were looking for an easy way to integrate our hardware accelerators into TVM. We noticed pretty quickly that we all had kind of the same goals, which was connecting our own accelerators to TVM. And we also noticed that a deep understanding of the underlying interfaces of TVM were necessary to reach that goal. So, to raise synergy, we decided to team up and build a modular interface. Essentially, UMA now provides APIs, classes, and file structures, and also examples for people to begin with to integrate new accelerators. So UMA effectively builds a second layer above the TVM APIs. To use the Linux terminology, porcelain and plumbing layer, UMA builds a stable Python-only API that has clearly defined templates for integrating new accelerators, and also has a pretty short learning period. That's why it targets hardware engineers as well as software engineers, especially those which are new to TVM. This wrapper then builds on top of the classic collage-like APIs and other TVM APIs, which are certainly more powerful and additionally also provide C++ interfaces, but require more experience. And here you can see how UMA is integrated into TVM. It consists of two major parts, the UMA partitioner and the UMA pipeline. Those two parts provide all the amazing functionality that TVM has in a condensed API tailored to accelerator integration. From relay pattern matching to TensorIR to CodeGen and many more. In the scope of this lightning talk, unfortunately, I can only give you a tiny part of the big picture. If you're interested in more, have a look at the recording from the community meeting from July 20. A major goal of the UMA community is also to provide good documentation and executable step-by-step tutorials. For this reason, we also created a user tutorial where a minimal accelerator called Vanilla that only can process conf2ds is integrated into TVM using the UMA APIs. Plan of the community is also to soon add more advanced templates to the tutorial. Currently, these are referred to as strawberry and chocolate accelerators in the tutorial and might deal with topics like hardware DMA or quantization. And that's exactly where the community needs you. When looking at the discussion forum for UMA-related posts, it is evident that there is a continuous discussion and new features are developed all the time. Most recently, the TVMC command line support. So if you have the same goals or are interested in UMA, I'd encourage you to participate. Everybody is highly welcome. The UMA community is currently looking for people who use their own accelerators and could maybe share experience how the UMA integration looks for them, test new features, and also support development of new features. The exchange here is happening in the discussion forum and also from time to time in the TVM community meeting. And that's already the end of this lightning talk. So let me summarize the most important points for you in a bit. UMA is an easy API for integrating your hardware accelerator into TVM. It has recently been mainlined and also added to the TVM release, and has a rapidly growing community with a lot of interest and more people who participate. For the future, new features are planned, like the ongoing TVMC command line integration, support for quantization, and the update of further integration templates, like the strawberry and the chocolate demo accelerator. Thank you very much for your attention. And as a side note, if these kind of topics are interesting for you, like AI compilers or hardware, check out the Encharge AI website. We are hiring.